Hi, welcome back to another installment in our long series of working with fractions. So, our last few videos, we looked at our adding, subtracting, multiplying, and dividing fractions. Also, in previous videos, we've gone through things like combining like terms, We've also actually gone through our 4 index laws as well. So a to the power of m times a to the power of n equals a to the power of m plus n. We've gone through a to the power of m divided by a to the power of n equals a to the power of m take n. A to the power of m to the power of n being the same as a to the power of m times n, and then finally a to the power of 0 equaling 1. And in this video, we're going to be calling on all of these. So think back to all of those videos, all of those lessons, and we are actually going to, in the next couple of videos, explore fractions a little bit deeper by applying all of these things to our fractions. Okay, let's jump on in. Okay, so to start off, let's go with one of our original fractions, and we'll use an addition problem. So we're going to go 3 over 2 plus 2 over 3. Now, what we remember from the last video is that we need to find a common denominator. And at such low numbers, the easiest thing for us to do is to just multiply these together. And that will give us a common denominator of 6. So we know that we want both fractions to have a denominator of 6. Now, to get 2 to 6, we need to multiply by 3. So we're going to multiply the top by 3 as well. And we're going to end up with 9 over 6. And we're going to add that to whatever the common denominator is for this one. So we're going to multiply that by 2. We're going to multiply 3 by 2 to get to 6. And then we're going to multiply 2 by 2 as well. And that's going to leave us with 4. Now, this is the same process we would have used for our last one, except this time, what I want you to start to get used to doing now is, because we have this common denominator here, we can actually express this as 9 plus 4 over 6. And it's exactly the same. We're just saving a bit of time on our writing. And this actually does the same thing, which leaves us, of course, with 13 over 6. But from here, we're going to take this right back to where we were actually looking at this stuff here. Now, I'm going to pose a new problem to you. How about throwing some algebra in with a plus 3 over 2 plus a take 2 over 3. Well, if we look at this problem here, it's really not all that dissimilar from this one up here. We've just added an a plus at the start of this and an a minus at the start of this one. But we actually work it out still the same way. So what we are going to do, we're still going to find our common denominator, and we're still going to use 6. So we are going to multiply this by 3. Now, think back to when we were expanding brackets and we were combining like terms. To multiply a plus 3 by 3, we actually put the brackets around it and we just put 3 at the front. And now that's actually going to signify to us that everything in the brackets, everything in here, just like everything up here, has to be multiplied by 3 to get what we want. And now we're actually going to do the same thing over this side here. So we're going to multiply this by 2 to get to 6, and we're going to put it in brackets by 2. And again, all this is telling us is that everything in this bracket here, which is above our fraction line, which is our numerator, gets multiplied by 2, just like our denominator did. So while up here, what we did to the bottom, we did to the top, we've actually still done it in this one here as well. So let's go ahead and let's start working it out. Now, just like we did over here, we can shortcut the next stage of this result by just understanding that 6 is going to be our denominator. Okay, we're going to have a nice long line so that we can fit everything on top. And now we're actually going to start to multiply everything in the brackets by what is outside the brackets. And so we end up with 3a plus 9, because 3 times a is 3a, 3 times 3 is 9. Then we're going to add, and the same deal over here, 2 times a. Well, 2 times a is 2a, and 2 times negative 2 is actually negative 4. And there we have the next stage in our algebraic fraction problems. So let's keep going. From here, our next step, remember earlier on in the video I said we're going to be looking back at combining like terms, and that's what we're going to do now. So our like terms, we know that 3a and 2a are like terms. So let's bring them down. 3a plus 2a, they are like terms, so we're going to put that together. We know that 9, positive plus 9, and 4 are like terms as well. And so that now becomes very similar to other problems that we've worked out when we've been combining like terms, and it's all over 6. But now that we've combined our like terms and we can actually work them out, we know that 3a plus 2a will result in 5a. Now, we also know that 9 take 4 leaves us with 5, but we know that it's positive 5. And it's all over 6. Now, we can't actually go any further than that, okay? Don't get too wrapped around the fact that there has to be only one value on top, like up here, and one on the bottom. That's not the way it is with algebraic fractions. If you have this here, if you have your variable and your coefficient along with a constant over something, then it works. If you've not got any like terms to cancel out, then you can't cancel out and you just stop right here. So if that went a bit quick, go back, rewatch it. If you've got any questions, please write them down, bring them to class, and we'll get a chance to work through them. Okay, catch you later.